In section 6.6, this is the first part of it, we're going to be graphing linear equations. So in this chapter, you will learn how to plot points, how to graph linear equations, and how to find intercepts. So we start off our discussion with the Cartesian coordinate system. The horizontal axis is called the x-axis. The vertical axis, or the vertical line, is called the y-axis. The point of intersection is called the origin. We call the first quadrant the area where both y and x are positive. When y is positive and x is negative, we have the second quadrant. When both x and y are negative, we have the third quadrant. And finally, we have when x is positive and y is negative, the fourth quadrant. So plotting points in ordered pairs. Each point in the xy plane corresponds to a unique ordered pair xy. So if I wanted to plot the point 5, 3, starting from the origin, I would move 5 units to the right. That would be my x coordinate. And then I would move 3 units up to do my y coordinate. So as you can see, my point is at 5, 3. So in this example, we're going to plot a parallelogram. The points are A, B, and C are 3 vertices of a parallelogram with 2 sides parallel to the x-axis. Plot the 3 points below and determine the coordinates of the fourth vertex, D. So our points are A, which is at 1, 2, B is at 2, 4, C is at 7, 4, and then we have to find D. So our solution is the following. A parallelogram is a figure that has opposite sides that are in equal lengths and are parallel. The horizontal distance between point B and C is 5 units. Therefore, the horizontal distance between the points A and D must also be 5 units. The question comes, well, why is it the horizontal distance between B and C is 5 units? Well, if you will recall that B is the point at 2 is the horizontal, x, 4, and C is at the point, horizontal is 7, 4. Therefore, 7 minus 2 is equal to 5 along the x-axis. We first want to note that this problem has 2 possible solutions. We're going to do the first solution first. So since we have 5 units along the x-axis, we have A at 1, 2, B at 2, 4, C at 7, 4, and the only other possibility in this particular configuration is when we have D at 6, 2. So in our second particular solution, we still have the 5 units from B and C. We know we have 5 units that has to be to A to D, but remember that D was originally here when we had the old solution. Now we're moving 5 units in the opposite direction, and it's still parallel to the 5 units of BC. So now we see that moving in the opposite direction gives us D to be at -4, 2. So graphing linear equations by plotting points. So in our particular case, a graph is an illustration of all the points whose coordinates satisfies an equation. All equations of the form ax plus by equals c, which is called the general form of a linear equation, where a doesn't equal 0 and b doesn't equal 0, will be a straight line when graphed. Thus, such equations are called linear equations in 2 variables. So by Euclid's proposition, since only 2 points are needed to draw a line, only 2 points are needed to graph a linear equation. It is always a good idea to plot a third point as a checkpoint. If no error has been made, all 3 points will be on the line or in the line, and that's called collinear. So to graph a linear equation by plotting points, we are going to have an equation. We're going to solve the equation for y. We're going to select at least 3 values for x and find their corresponding values of y. We're going to plot the points, and the points should be in a straight line. We're going to draw a line through the set of points and place arrow tips at both ends of the line. So our first equation in graphing an equation by points is we're going to graph y is equal to 2x plus 2. And from this, we're going to create the following table. So we're going to allow x to be the following points. X is going to be either 0, 1, or -1. When we plug these back into the equation, we get 2 times 0 is equal to 2 for y. When x is 1, we get 2 plus 2 is equal to 4. When we let x equals -1, we get 2 times -1, which is -2, is equal to 0. Now, we'll plot the points. We had the points 0, 2, which is this point right here. We had to plot the point 1, 4, which is here. And finally, we plotted the point -1, 0, which is here. Now we drew a line through those points, and we put in arrows on either side. There are 2 features here we want to discuss. One is when the line crosses the y-axis, like it does here at 0, 2, we call that line the y-intercept. When the line crosses the x-axis at -1, 0, we call that point the x-intercept. Hence, we can graph equations by using the intercepts. That is, the point where the line crosses the x-axis is called the x-intercept. The point where the line crosses the y-intercept is called the y-intercept. Typically, these points are the following. For the x-intercept, we have where x is the number, but y is always 0. This is the x-intercept scenario. When we have the y-intercept, we have x is the 0 and y is a number. that's considered the y-intercept. To find the x and y-intercepts, we have the following conditions. To find the x-intercept, we set y equals 0 and solve the equation for x. To find the y-intercept, we set x equal to 0 and solve the equation for y. So, in this particular case, we're going to graph an equation by using the intercepts. So first of all, we're going to graph 3x plus 6y is equal to 12. To find the x-intercept, we set y is equal to 0 and solve for x. When we do that, here's our original equation. And now we'll put in 0 for y. And we get 3x plus 6 times 0 is equal to 12. Now you know that the 6 goes away, and we're left with 3x is equal to 12. So that means that x, when we divide both sides by 3, we get x is equal to 4. The x-intercept is 4, 0. Now we're going to graph the equation by using the intercepts again. To find the y-intercept, we set x equals 0 and solve for y. So we start off with 3x plus 6y is equal to 12. So now 3 times 0 is 0, and then we have 6y is equal to 12. That means we have the equation 6y is equal to 12, or y is equal to 2. So the y-intercept is 0, 2. As a checkpoint, we're going to substitute x equals 2 and determine the value of y. When we do that, we have our original equation. We'll put 2 in for x. We get 3 times 2 plus 6y is equal to 6, is 12, I mean. 6 plus 6y is equal to 12. And now 6y is equal to 6, so y is equal to 1. So our checkpoint is the point 2, 1. Now we're ready to graph. We had found that the x-intercept, of course, was 4, 0. And we found that the y-intercept was, in fact, 0, 2. Finally, our checkpoint was 2.1. All of those fall in the same line. We draw our line, and we put arrows at the tip. So that's how we're graphing an equation using the intercepts. This concludes part 1 of chapter 6.6. The things that you should be interested in knowing is how a linear equation general form is. So it's ax plus by is equal to c. Then we know what the x and y intercepts are. If we let x equal 0, then we find the y-intercept. If we let y equal 0 in the equation, we find the x-intercept. So in our next part, we are going to be graphing using the idea of slope and y-intercept.